we'll start the divergence of a vector field. Divergence of a vector. Divergence of a vector. Divergence of a vector. Now, divergence of a vector. Divergence of a vector function. Divergence of a vector function. A function of x, y, z equals to ax I cap plus ay j cap plus az k cap is defined as div A, div A, or this is equals to divergence of A. Now we put a dot product here. Okay, divergence del dot A. Okay, divergence of A. This is called the divergence of A. So this is equals to I cap del del x plus j cap del del y plus k cap del del z dot ax I cap plus ay j cap plus az k cap. So it is the dot product now. So if you take the dot product, then what's happened? I dot I 1. So this is equals to del ax plus del ay plus del az del z. So this is the divergence of A. Divergence of A. So you can see that divergence of A is a scalar quantity. Dot product relay that becomes a scalar quantity, we know that, and also it is a scalar quantity because in the right hand side there is no unit vector. So divergence of A is a scalar quantity. Divergence of A is a scalar quantity. Now, what do you mean by divergence? Divergence means if the divergence of any function, vector field function or vector field is positive, that means that field is coming out from a point. Diverge. Okay, divert means it is coming out from a point. So, if you take a positive charge plus Q, then what happened? Then what is the electric field? What is the direction of the electric field from the positive charge? What is the direction of electric field from a positive positive charge. From positive charge, the electric field is coming out. Okay, so the electric field is like this. So this is the divergence. Okay, and here the divergence is positive. Divergence of the electric field is positive. Okay, now if we take a negative charge, then what's happened? Then the electric field is converging. That means it is coming like this. This is called the convergence. So when the electric field or the field is converging, then the divergence of that field is negative. Okay, so here we have the divergence of E equals to negative, and here divergence of E is positive. Divergence of E is positive. Okay, so and if the divergence of E is positive, then we say that that is the source. Source of electric field, source of water, source of gravitational field, anything. Because it is coming out from a source. And if the divergence of E is negative, then that is called sink. Sink. That means what is called a tank, water tank. Water is coming inside the tank. So it is the sink. And when that is also the source. When the water is coming out from the tank, that is the source. And when water is put in the tank, that is called a sink. So the water tank is sink and source. Whether it is coming out or not, converges at that point. That is called the source and sink. Now, physical significance of the divergence. Physical significance of divergence. Divergence of a vector field. Vector field. Physical significance of the divergence of a vector field. Look, the divergence of a vector field. The divergence of a vector field indicates the net outflow. Indicates the net outflow NET. Net outflow or flux. Net outflow or flux evaluates flux of that field or unit volume. Net outflow or flux of that field or unit volume. Full stop. If a vector function A, was a vector function spread out, spread out from a point. If a vector function A spread out from a point, then it has a positive divergence. At that point. And the point act as a source of the field A. Act as a source of the field A. Source of the field A. Act as a source of the field A. Act as a source of the field A. On the other hand, if the field A converges to a point, then divergence of A is negative. Converges at a point, then divergence of A is negative. At that point, divergence of A is negative at that point, and the point act as a sink, for the field A, and the point act as a sink for the point for the field A. Okay, so this is the physical significance of the divergence. Now, solenoidal vector. So we can say that if the divergence of E is positive, then that is a source, and if the divergence of E is negative, then it is a sink. Okay, and positive negative the field are coming out, and in the negative it is converges at the point. Now, if the fields are parallel to each other, not converges, not diverges, then what happens? Then divergence of the field is 0. Okay, not negative, not positive, that is 0. So divergence of A equals to 0. And if divergence of A equals to 0, then the vector A is called solenoidal vector. Okay, solenoidal vector. Solenoidal vector. Solenoidal vector. If the divergence of a vector field A, if the divergence of a vector field A is 0, if the divergence of a vector field is 0, that is divergence of A equals to 0, then the vector A is called solenoidal vector. Solenoidal vector. Okay, solenoidal vector. Now solve a problem. देखो देखो problem 1. Find the constant m, small m. Question. Find the constant m, small m, so that the vector find the value of constant m so that the vector a equals to x plus 3y I cap plus y minus 2z j cap plus x plus mj k cap is solenoidal. There is value of m. All are x, y, z, but here there is m. M is a constant. Find out the value of that constant m so that the vector A is solenoidal. Now find the solution. So what is the condition for solenoidal? Find out the divergence of A, and that is equal to 0. After the unit for the 0, y is constant. Only delta x, delta x is 1. Delta y is 1. देखो जरा पढ़ो नहीं देखो if the vector A is solenoidal, then divergence of A equals to 0. Then divergence of A equals to 0. Minus 2. Divergence of A equals to 0. Or I cap delta x plus j cap delta y plus k cap delta j dot x plus 3y I cap plus y minus 2z j cap plus x plus mj k cap 3y plus del del y plus y minus 2z plus del del z x plus mz equals to 0. Now, this is the partial derivative. So, del del of x is 1, del del x of y is 0, plus del del y of y is 1, del del y of z is 0, plus del del z of x is 0, plus del del z of mz is m equals to 0, or m equals to -2. So you will do the solve the problem in this way. Okay. Shortcut program. If you do the solution shortcut, then you will give the number in shortcut. Divergence of A equals to 0 for a 2 4. Now similarly, if the question is given that like that, a field is given. Okay. So that whether it is a source or sink, because a vector is given, then we will show that whether it is a source or sink. You have to find out the divergence. If divergence of is positive, then the source, and if it is negative, sink. Between. Now we go to the curl. Curl of a vector. CURL, curl of a vector. If vector A is a differentiable vector function, if vector A is a differentiable vector function, vector A is a differentiable vector function, then the curl of the vector is defined as, then the curl of the vector is defined as curl of A, that is now the cross product, okay, that is divergence curl dot, now it is the cross product, okay, curl of A. So this is equals to I cap del del x plus j cap del del y plus k cap del del z cross ax I cap plus ay j cap plus az k cap. So how we find out the cross product? By determinant. Okay. So this is equals to I cap, j cap, k cap, del del x, del del y, del del z, ax, ay, az. Now find the determinant. Find the determinant. Yeah, this is equals to first is I cap del az del y del az del y minus del ay plus minus তাই তো or minus j cap কি হবে del del x del x minus del ax del z plus k cap del ay del x minus del ax del y. So this is the curl of a vector. Curl of a vector. And you can see that in the vector quantity. The curl of a vector is a vector quantity. Curl of a vector is a vector quantity. So, if the curl is a vector quantity, then what is the direction of the curl? First, what do you mean by curl? Curl কাকে বলে? Physically, it is the mathematics. Anyone? Curl means rotation. Rotation along a point. Or with a point. That is called the curl of a vector. Okay? So, if a vector is rotating, okay? If the vector A is rotating about a point, A is rotating about a point, then what is the direction? A vector is rotating like this in the anti-clockwise direction. Then what is the direction of the curl of A? According to the right hand thumb rule. Okay? According to right hand thumb rule. So, if all the vectors, all the fingers of the right hand denote the direction of the vector A, then the thumb of the right hand is the direction of the curl of that vector. Okay, curl of that vector. Now, what is the physical example of curl? So, if the vector A is rotating anti-clockwise, then it goes up. Curl of A is up, upward direction. And if the vector rotating in the clockwise direction, then it goes down. Curl of the vector goes down. Direction of the curl is in the downward direction. Now, what is the physical example? In nature, cyclone কি হয়? In cyclone, the air is rotating like this and it goes up. Why? In the curl. Okay, so why anything which is inside the curl, that is the vector, that is the wind, all goes up, goes to the upward direction. Okay, so you can after cycle, দেখবে গাছের উপর অনেক কিছু পাওয়া যায়, বুদ্ধিকার উপর মানুষের উপর থেকে। Why? Because the force is along the upward direction. Okay? যেটা বেশিরভাগ থেকে আমেরিকান সাইক্লোন গুলো হয়, এখানে দেখো ঘর বাড়ি সব উপর দিয়ে চলে যায়, শুধু ভেঙে দিয়ে সব উপর দিয়ে যায়। That is the part. Again, if you go to the river, in river you can see that in some places there is a rotation of the water along the water direction and the water goes down. দেখি যে water deep আছে, তাই না? সেই জন্য বলা হয় when you go to swimming, don't go there. Why? If you go into that point, then you go to the downward direction. That is the curl. Okay, that is the physical example of curl. देखो ताले Physical significance. Physical significance of curl of a vector. Physical significance of curl of a vector. Curl of a vector. Curl of a vector field. Curl of a vector field at any point indicates the amount of rotation, of that vector, indicates the amount of rotation of that vector about that point. If a vector A rotates around a point, then its curl is non-zero. Full stop. Full stop. The direction of curl A, is the thumb of the right hand. When the remaining fingers follow the lines of vector A. When the remaining fingers follow the lines of vector A. Vector triangle. Okay. Now, as I told you above, when there is a rotation, then what happens? The curl of the vector is non-zero. Right? The curl of the vector is non-zero. So the curl of the vector is either upward direction or downward direction. Now, if the curl of A is zero, then what happens? Then that is called irrotational vector. Right? If there is a curl, then that is called the rotational vector. That is, the vector is rotating. And if the curl is zero, then it is irrotational vector. That means the vector is not rotating. Okay? Irrotational vector. Irrotational vector. If the curl of the vector A is zero, then the vector A is called irrotational vector. If the curl of A is zero, then the vector A is called we have completed gradient, divergence, and curl. Okay. If divergence of vector is 0, then that is called solenoidal vector, and if the curl of the vector is 0, then that is called irrotational vector. Okay. In the next class, we will solve some numerical problems of vector. Then we will start the module 2 oscillation.